Let p sub 1 of x equal p of x be a polynomial. For integers n greater than or equal to 2, define p sub n of x equals p of p sub n minus 1 of x. Prove that the polynomial p sub 2021 of x minus 2 p sub 2020 of x plus p sub 2019 of x is divisible by the polynomial p of x minus x. So I want to share with you an interesting question that I saw online the other day. Hopefully my video quality is better than it was on my first video. So let p1 of x equal p of x be a polynomial. Okay, so we have some polynomial, and let pn of x equal p of pn minus 1 of x for n greater than or equal to 2. So the composition. Okay, so we have a polynomial, and then we're going to have a number of polynomials each. You get the next one by taking the composition with the previous one. We want to show that our initial polynomial minus x divides the polynomial p of 2021 of x minus 2 p of 2020 of x plus p of 2019 of x. Okay, and this is for all polynomials. I guess other than the polynomial x, right? That'd just be dividing by 0. So we'll say all polynomials that are not x. Okay, so the first thing I want to, I guess before we get started, pause the video, try it on your own, and let me know if you get an answer. All right, so the first thing I want to write is that p, in general, p sub n plus 1 of x is equal to p of n composed with our initial polynomial. Okay? And so why is this true? Well, it shouldn't be too surprising. What's p of n plus 1 of x? That's p of p of p of dot 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 of p of x n plus 1 times right? There's n plus 1 p's here. But notice if you ignore this inside term, there's n p's. And so that's going to be p sub n composed with p of x. Okay? So that's fact 1. Fact 2, so what's fact 2? It's for a and b, a to the n minus b to the n is equal to, well, we could factor out an a minus b. And what do we get left over? We have a to the n minus 1 plus b a to the n minus 2 plus dot 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 plus b to the n minus 2a plus b to the n minus 1. Okay, and so that's true for n greater than or equal to 2. And then obviously when n equals 1, you'd have a minus b is equal to a minus b, and then that term would just be 1. So we'd have a special case when n equals 1. But either way, a minus b divides a to the n minus b to the n for n greater than or equal to 1. Okay, so consider the nth composition here. So the nth composition is still a polynomial. So we could write it as some constant term plus a number times x to the first plus a number times x squared plus some number times x to the r. R here would be the degree of this nth composition. And what we're going to consider is consider p sub n plus 1 of x minus p sub n of x. Okay, so consider this polynomial. Well, we know from 1 that p sub n plus 1 of x is equal to p of n composed with p of x. Okay, so we could rewrite this as p of n composed with p of x minus p of n of x. And using our expansion, this is equal to, well, Pn composed with p of x, just replace every x with p of x. So C0 plus C1 p of x plus C2 p of x squared all the way to CR p of x to the r minus, so that's this term, minus p of x. C0 plus C1x plus C2x squared plus CR x to the r. Okay, notice constant terms cancel. And what are we left with? We're left with, well, the sum from, let's say, k equals 1 to r of ck p to the k, so p of x raised to the k power minus x to the k. And we know from 2 that p of x minus x divides each term in this. Okay, so p of x minus x divides p sub n plus 1 of x minus p of n of x for all n. Okay, and now we're basically done. Right, we showed p of x minus x divides p of n plus 1 minus p of n of x for all n. And so how do we finish? Well, note that our initial polynomial, so p of 2021 of x minus 2p 2020 of x plus p 2019 of x is equal to p of 2021 of x minus p of 2020 of x, which we know p of x minus x divides, minus the quantity p of 2020 of x minus p of 2019 of x. Okay, so p of x minus x divides each of these terms, so p of x minus x divides the whole polynomial. And that's it. Let me know what you think. Was the video quality better? I think it was. I hope it was. Let me know if you want to see more videos like this. I know this wasn't combinatorics, but I thought it was an interesting problem. Yeah, let me know any thoughts you have in the comments, and I'll try to get back to as many as I can. All right, bye-bye.